I will tell everybody this is being recorded for replay on YouTube, so be aware of that in our conversations. Also, I want to make the point that if you have particular SRs that you are concerned with, this is not the forum for which to discuss those. This is a Q&A session that should keep questions, specific to the functionality and of the general nature, and not a specific support issue. I'm Mark Scardina, and I'm joined this month with Prasanth, who I will let introduce himself as a member of the Cluster Health Monitor Development Team.
Yeah, hi everyone, I'm Prasanth. I have been in Oracle for over 11 years now. I have been primarily involved in design and development of GIMR. My primary areas of interest include Linux system programming, applied ML and data diagnosis relevant to monitoring frameworks.
Okay, thank you. So before we get too far along, I want to point out here that since we do have a developer in the midst here, there may be something that's stated that is future facing, and so be aware of our safe harbor statement that is active for this presentation. Additionally, everyone is muted except myself and Prasanth, and so we ask that all questions be typed into the chat, and we will get to them during the course of this session. So please use the chat function to ask your questions, and you can do that at any time. In fact, you can actually do that now, because we're going to initially open it up to anybody who has questions coming in. We do have some seated questions, should you not be prepared to ask one quite yet, but I'll initially open up the queue here for any questions that somebody might want to enter in the chat. Okay, well, let's kick things off, Prasanth, and with sort of our first question, which is, what is Oracle's goal in developing Cluster Health Monitor?
Yeah, the goal was to essentially develop a monitoring entity that is integrated with the Oracle ClusterWare stack. And the idea was that it should have certain characteristics. So let me just list down certain important goals that we had in our mind while building this monitoring component. So one requirement was that it should basically aid in online and offline data diagnostics. So as part of offline data diagnostics, the idea is that basically we should have all key metrics that would aid in doing root cause analysis. As part of online diagnostics, the idea is that the monitoring component should be tightly integrated with the rest of the Oracle stack. So the idea here is that this tight integration with rest of the Oracle stack would basically give us a better contextualized view of the system that we are monitoring. This contextualized view would essentially help in capturing first failure diagnostics in an autonomous fashion. The way we would capture them would be using events. So the various components that we are monitoring can essentially raise certain events, and we can take appropriate actions which can aid in diagnostics. So that is first point, online and offline diagnostics. Okay. The second point is that basically it should collect this data even when the system is under duress. So it should be able to collect critical last gasp metrics. That is second point. And the third point is that while we collect all this data, we should be as efficient as we can. So we basically use the underlying native OS interfaces to capture all this data in as efficient fashion as we can.
Okay. All right. Well, that sounds like quite a laundry list of requirements here. Let's see how well we delivered on them. So you mentioned about diagnostics and metrics. So what type of metrics does CHM actually retrieve?
Yeah, so we actually collect various categories of metrics, and some of them may or may not be available depending on the actual version of the clusterware stack that is being used. So I'm going to list few of them. We have system metrics. So these metrics, these category of metrics essentially gives a high-level overview of the entire system. Then we have process-specific metrics. We have process aggregate metrics, which we will look at in next slides. And we have device metrics. These are essentially disk-specific metrics. We have NIC metrics, network interface card metrics. We have file system-based metrics. We have protocol metrics. By protocol, I mean network protocol metrics like TCP, UDP, etc. We have NFS stats. We have ADVM, ASM Dynamic Volume Manager metrics. We have ASM instance-specific metrics, etc.
Wow. Okay, that's quite a list of metrics. So how often are these metrics collected?
Yeah, so the default collection is basically 5 seconds. So there is one category of metrics called process metrics. If there are many processes in the system, it is possible that process metrics could get delayed. But the core metrics always get collected at 5-second intervals.
I see. Okay, well, that's quite a few metrics and a reasonable frequency. So what is the cost of these metrics collections from a standpoint of resources?
Right. So in terms of CPU utilization, we consume about anywhere between 1 to 3% of CPU usage. And in terms of memory consumption, we consume somewhere around 50 to 60 MB in terms of RES, which is actual memory consumed in RAM.
Okay, well, that doesn't sound too bad. I assume that's across individual nodes based on the architecture. You want to address the architecture a little bit here?
Yeah. So we essentially have two major daemons as part of GEM. So one is osysmond, which is the basic metric collection daemon. And we have ologgerd, which is the aggregation and logging daemon. So there is a osysmond running on every node in the cluster, which essentially collects all the metrics and sends it across to ologgerd. And there will be one ologgerd running in the entire cluster whose job is to basically aggregate all the metrics that it receives from all the sysmonds and then log it to a repository. The repository that we are currently using is an Oracle database, and we call it GIMR. It is shipped as part of clusterware, and it is self-managed. So additionally, osysmond also has something called a local log, which is a circular binary file. So the purpose of this local log is to basically add resilience to network failures. In case there is any problem in sysmond talking to loggerd or any problem with respect to loggerd talking to the database, all the packets get logged to the local log. So every packet that gets, by packet I mean this basically the payload which has all these metrics that we just talked about. That gets sent to GIMR, gets acknowledged back to osysmond. So if and only if the packet that has been sent to GIMR has been successfully inserted in the database, we actually invalidate the entry in our local log. So this has all resiliency built into it to make sure that we don't have any data loss.
Okay, that sounds like a very reliable flow. So I see here that there are two daemons involved, osysmond and ologgerd. Are these managed by CRS?
So osysmond is a OHASD resource. It's not a CRS resource. So osysmond is all managed by internally by clusterware. So the customer doesn't have to specifically manage this resource. ologgerd is a daemon that is internally managed by osysmond.
I see. So actually the sysmond spawn the ologgerds. Is that what you're saying?
Correct. Sysmond actually spawns and manages ologgerd. It takes care of it, on failures, etc.
Okay. So you mentioned that there is a resource, the CRF resource. Can I manage or modify it myself as a user?
So a user is not expected to mess with this resource. It is all self-managed. It is managed by OHASD. So user is not expected to intervene with this resource.
I see. Okay. By the way, anybody who has any questions, please just jump into the chat and post them, and we'll get to them as appropriate. So you showed that there was one ologgerd daemon running for the cluster, which all the sysmonds plugged into. So if that node goes down or is evicted from the cluster, what happens to the ologgerd?
Yeah, that's a good question. So basically, it's the job of all the osysmonds to do the lifecycle management of ologgerd. So if a ologgerd, for instance, gets killed or crashes on a given node, osysmonds would first, the local osysmond on that specific node would first try to restart it. If it hits repeated failures as it tries to restart ologgerd, then all osysmonds would go ahead and elect a new master node, and ologgerd would be spawned on the newly elected master node. If the node itself where ologgerd is running goes down, the same thing happens. All other osysmonds would detect that they don't have a ologgerd running in the cluster, and they would elect a new master node and spawn ologgerd there.
I see. Okay, so when this happens, does CHM lose any data during this switchover to different ologgerds?
No. So as I was mentioning in the architecture, we have that binary local log. So basically what happens is that during the time of switchover, where basically ologgerd is not available. So all this data that has been generated during that time frame is going to be locally logged. And once ologgerd becomes available, all this data would be replayed and again be inserted into the management repository.
All right. Okay, that sounds good. So as a cluster owner, do I need to actually enable Cluster Health Monitor to take advantage of it?
Yeah, one doesn't have to explicitly enable Cluster Health Monitor. It is enabled by default. It comes up as part of the clusterware stack automatically.
I see. So it starts up with the cluster itself and is immediately monitoring?
Correct. In fact, it is one among the very first few resources that comes up.
Okay, so I'm aware that during certain patching or upgrade problems, certain daemons need to be managed or shut down. Should I disable cluster health monitor during patching or upgrades?
No, so cluster health monitor shouldn't be disabled during patching and upgrades. It is completely rolling upgradable, and the user is not supposed to disable it during that time. I mean, if one disables CHM during that time frame, I mean, one would basically lose crucial diagnostic data if they run into any problems.
Oh, so it is actually active during this process as well.
Correct, correct.
I see. So in that case, how do I know that cluster health monitor is enabled and working?
So one can use standard CRSCTL command to find out what is the status of CHM. The corresponding name of the resource is ora.crf. So one can use CRSCTL status res ora.crf -init, and it will basically tell, okay, what is the status of the resource.
I see. Okay. So from that diagram, I see that you said that ologgerd is inserting the data into the management repository. Therefore, I assume the management repository is a requirement for CHM to work?
Yes. So currently, GIMR is a required piece of entity. But the way we have designed and architected CHM is that one can, so this is just an centralized repository, GIMR. If you want to, tomorrow we can essentially insert or persist all this data into any other centralized repository. It has been layered in a fashion that rest of the monitoring and the logging and aggregating framework would be independent of the underlying repository that is being used.
But we don't do that today.
Correct.
You're saying in the future we could do that. Is that what you're saying?
Potentially do that, yes.
I see. So, but right now, today, it's a requirement through 18. Correct. And they recently introduced 19. Okay. So we've talked about getting metrics in and the broad goals that you mentioned at the start. So what specifically are the CHM metrics and their data used for?
Yes, so one category is basically like offline postmortem analysis. Basically, you have all the metrics and you go look at the metrics to find out what is the root cause. And the other case is basically online analysis. So in this case, we have tighter integration with clusterware components. So one component, so I'm just listing out the components. So one component is CRS. So CRS uses CHM metrics for server portal categorization. Another component that uses CHM is CHA, Cluster Health Advisor. So it uses our data and then combines it with DB metrics to basically give smart alerts and basically give actions, recommend actions. And there's another component that also uses CHM, which is memory guard. So it actually consumes CHM memory metrics, basically to provide its functionality. So all this data is consumed by those tools at runtime dynamically all the time. It consumes all this 5-second sampling data that CHM constantly generates.
So other components in the autonomous health framework are using CHM as their data source for OS metrics. Correct. If I understand you correctly.
Correct.
Exactly. I see. So you also mentioned that I can use them for postmortem or analysis. So how do I get access to CHM data?
So there are two ways to get access to CHM data. So we have a CLI, command line utility called osysmond. And there's also an utility, one can also get this data through EM Enterprise Manager. there is a section in EM to actually look at CHM-specific data.
So I have an example of a command. You want to walk me through what this command looks like and does?
Sure. So earlier, I talked about these various subcategories of metrics that we collect and that one can query for. So Oklumon is the basic CLI that I just talked about, and dump node view is the verb that is used to actually query data. So Oklumon also has certain other verbs for different purposes, things like for managing the repository, managing the log level, etc. So as part of, when we say Oklumon dump node view, it essentially means that, okay, I want to now query the metrics, and then there are various sub-filters to this option. So there is a filter called proc AG, which stands for process aggregates. So we are saying that, okay, show me only the process aggregates. And then there is a filter option saying all nodes. So this is basically saying, show me the process aggregates of all the nodes in the cluster. So in this example, we are basically seeing the process aggregates for node 1 and node 2. And let me just walk through what do we mean by process aggregates. So what we essentially do is we capture each and every running process in the system once in every 5 seconds. And then we essentially identify what type of process it is. Is it a cluster-aware specific process? Is it a database background process? Is it a database foreground process? What is the set of that process if it is a database process? Is it an ASM process? Is it a iOS process? Is it an Apex process, etc.? So we essentially tag every process. So this is the first step. So once every process running in the system is tagged, we basically do metric aggregation across these various categories. So what we are seeing here is basically aggregation of these various metrics across all these categories. So if you just look at the first column, what we are seeing is the percentage CPU usage. So what this essentially tells us is that out of the overall CPU that is currently being utilized in the system, which category is consuming what percentage of that CPU. So in this example, 92.89% of the overall CPU that is being utilized in the current machine is being consumed by DB foreground process of prod1 database. So
I see.
And then the next one is basically the aggregate private memory utilization, and the units is in kilobytes. And the next one is max shared memory. The very next one is total number of threads summed across all the processes belonging to that particular category. And similarly for total number of FTs, total number of processes, and then the actual category of the process. And then there is a SID field, which is only relevant to database processes.
I see. So this CPU usage over here is different from these in that it's not an absolute value of what the OS thinks it's CPU. This is just a percentage of how much CPU is being used in the box. So if the box was 60% utilized, this 92% would be of the 60%, right?
Correct. Basically, if you want to get the
where these are absolute numbers.
Yes, if one wants to get basically these would sum up to 100. And if one wants to get the absolute number, this needs to be multiplied with the actual CPU utilization at that point of time. And that can also be gotten by using the dump node view option without this filter. Or one can also add the system section to this.
Yeah, okay. So you also mentioned about EM functionality and that it could be accessed from EM. So maybe you can talk a little bit about this screen in EM.
Right. So the one that we looked at earlier is basically a CLI, and so obviously it gives textual output. So as part of EM, we have a graphical output. So there is a subsection in EM under which one can actually get to view CHM data. So as part of this view, if you guys see, we can actually see the metrics for every node. So probably the resolution is small, but there are like 4 nodes in here, each of them represented by a unique color. And there are like, I think at least 3 high-level metrics that are being shown here, basically the CPU utilization, memory utilization, and total transfer rate. So this must be the network utilization. So this is the high-level overview of these probably 3 or 4 OS resources for every node. And then there is also an option to drill down into a particular node by actually clicking on that node specific marker, and one can actually get further detailed metrics about that particular node.
And then I see there's a calendar here.
Yes, so the one can also look at historical data, and then one can use this calendar to basically pinpoint the data that they want to look at. Basically, one can fix the frame of their window. Basically, I want to look at the data for so and so time frame, or so on from so and so start date to so and so end date.
Okay. So this data is coming from the management repository, not from EM then, correct?
Yes. So yes, this data is not coming from EM agent, but is actually coming from the management repository that I was referring to earlier.
Okay. Okay. So in that case, do I have control over how much data I can store in the management repository? And sort of,
yes.
Is there a default or?
Yes. So by default, we actually have retention set at 3 days.
I see. So if I want to configure that, can I do more or less?
Yes.
How do I do that?
Right. So I was referring to the osysmond CLI earlier, and I said that there is a manage option to that. There is a verb within manage called repos. So one can basically use osysmond manage to change the retention. So one can change retention in actually 2 dimensions. So one dimension is basically time. So one can basically say, okay, make sure that my retention is for X number of seconds. The unit is in seconds. And the other dimension is in terms of space utilization on the disk. So one can say, okay, maybe I have got, I don't know, 100 GB of free space, and basically I can say that, okay, use all that 100 GB of free space and give me as much of retention as you can. So one can set retention both in terms of time and space. And the command would actually, so if you set retention in terms of time, and if the command goes through, it will also tell you what is the expected space utilization. Similarly, if you try to set the retention in terms of space, the command would also tell us what is the approximate expected retention in terms of time. That is how much of data in terms of time can it store given that space requirement.
I see. So, okay, so it gives me a significant amount of flexibility there. So just a reminder to everybody, because we had some new people join, if you please feel free to ask any questions, but use the chat because everybody is muted. So please type your questions to everyone in the chat and we'll get to them. So coming back to our questions here. So you talked about the categories of metrics that CHM collects. Do I have any control over what specific metrics I can have CHM collect?
So the core piece of metrics, those are always collected at 5-second interval, and the reason being that the problem could be multi-dimensioned and we don't know what are the dimensions of the problem. So the core metrics are always collected at 5-second interval. Additionally, there are certain extended set of metrics that get collected in an event-driven fashion. So these metrics are only collected when certain events are generated by some specific components.
Okay, but do I have an ability to customize the metrics in any way?
No. So there are fixed set of metrics that are collected as part of core metrics. And they are always collected at 5-second interval.
All right, but you mentioned about the processes that are being collected. If, as an example, if I say, and you said that we're collecting the top processes. If there's a process I always want to monitor, is that something that I can tell CHM always give me that process?
Yes. So there is an option as part of Oklahoma Manage to essentially pin certain processes. So what happens is that as part of CHM collection, we collect data for each and every process running in the system. And we actually send this data to management repository, right? But before we send all these metrics to management repository, we do something called filtering. Because there could be thousands of processes running in the machine. So it won't be practical to basically send the process metrics for each and every process running in the system. So we do certain filtering. So that filtering is based on certain criteria based on which we consider that process to be interesting. So we look for top consumers and also certain Oracle processes. In addition to that, we would also always send specific set of processes which have been explicitly pinned. So we have a default set of processes that we always pin. So these processes would include certain critical processes like CSS, etc. So by pinning this process, we will make sure that this process always shows up as part of Oklahoma daemon view data that we query from ngmtdb. Additionally, if a user wants to pin some specific process, they can also do it by modifying the pinned list through Oklahoma command.
So I can actually, if I have some sort of key processes that I want to always monitor, instead of waiting for them to pop up in the top consumers list, I can specify those to be continuously monitored by CHM.
So if a process is pinned and that process actually doesn't show up in our Oklahoma daemon view, that essentially means that that process is dead. A non-pinned process might not show up because it is not an interesting process or a top consumer, but a pinned process should always show up as long as it's running.
Okay. Okay, so I saw various outputs that from CHM to EM and to the command line, but is there any way that CHM sends out notifications should, for example, metrics exceed certain levels?
Right, so the problem with, there are various problems with threshold-based notification. I mean, threshold-based notification is basically like, okay, it's like I'm trying to find out a size that fits all, right? So there is a smarter way through which we want to handle notifications. So what we essentially do is this CHM data is actually consumed by upstream entity called CHA. So it actually consumes the CHM metrics and also DB metrics. And it actually generates certain advice or actions based on CHM data. And it does this by using pre-configured, pre-calibrated models.
I see. So basically, we offload that task to other AHF components that have more insight into what else is going on in the system than simply metrics collected by CHM.
Correct.
Okay. So we have a question from our audience. Kieran asks, if I already have infra monitoring tools such as New Relic or AppDynamics in my environment, can I use them in conjunction to CHM? And if so, can I pick and choose which metrics get monitored?
Sure. So it can obviously use in conjunction to CHM. So as I was saying, CHM has tighter integration with rest of the components, right? So these external monitoring entities obviously are not integrated with rest of the clusterware components. And I guess there was one more part to that question. If you could.
Yeah, if so, can I pick and choose which metrics get monitored?
Okay, so that we currently don't have. So as I was saying, we have certain core piece of metrics that we always want. So we don't provide a way to basically turn off certain metrics because it's very much possible that metrics are a requirement for our upstream tools. So just because the same metric is being collected by some other entity doesn't mean that we would want to turn it off here, because there's a dependency on these metrics for our internal tools.
Sure, that makes sense. Okay, so we talked about the fact that CHM depends on upstream AHF components for notifications, but since we send data to EM, can I set the thresholds in EM for this data to get notifications from EM?
No. So this facility is only available for data that has been collected through EM agents. The CHM data is not collected through an EM agent. EM directly talks to MGMTDB through SQLnet and basically gets the data. And currently there is no way to basically set thresholds for that data stream in EM.
So you're saying that EM pulls data from the management repository by virtue of going to the pages instead of having the management repository push data to EM so it can set thresholds.
Correct.
I see. Okay. All right. So how is CHM data in EM different from what I already see that you referred to when the EM agent collects data?
Right. So we have, so as part of CHM, we have a richer data set in the sense that we have much broader metrics. That is one thing. And second thing is also the data collection frequency. CHM basically collects data at 5-second intervals, and EM default frequency is 1 minute. And additionally, as part of CHM data, you also get to see clusterized view. But as part of EM agent data, one gets to see only node local view. Basically, one has to switch across multiple nodes, and one can't get to see the correlation of the same metrics across multiple nodes. There's no clusterized view for EM data.
I see. And so in the screen here, can you describe what we're seeing here?
Right. So basically, this is the CHM data metric section in EM. So as I was just referring to, basically the top level view will basically show the metrics across all the nodes. And this is the clusterized view that I was referring to. And then one can also additionally drill down to a particular node and basically get more detailed metrics specific to that node.
So what I'm seeing here is it appears to be, is this core level metrics?
Yes. So once we drill down to a particular node, so in this particular section, we are basically seeing per core utilization across all the cores in that machine. So this is also like additional data which we don't get through EM. So and this data is also sometimes very useful because when you don't have per core view, you only get to see the overall CPU utilization. And on machines where they are like a large number of CPUs, it's very much likely that even if one particular core is extremely overloaded, you won't basically notice it as part of the overall CPU utilization because there are just too many CPUs. But that one core that is being overloaded could essentially be a bottleneck. For instance, if that core is responsible for handling interrupts, etc., it will cause performance issues if it goes unnoticed.
I see. Okay. All right. That sounds valuable. So you mentioned that obviously CHM is within the grid infrastructure. So which versions of the grid infrastructure support CHM?
Yeah, so initially CHM came out as part of OTN, and later we had integrated with ClusterWare. So it has been first available as part of 11.202 in Linux, and later we have also added support for Windows as part of 11.203. And support for Solaris, both for x64 and Spark flavors. We also have support for CHM in AX and ZLinux. So as you guys can see, basically, I mean, this product has been around for quite some time. And it has been field tested and is very stable.
I see. Okay, so it's basically been around since 11.2, which is quite a few years. So does CHM functionality, even though it's hosted within the grid infrastructure, does it care which versions of the database are running in my cluster?
No. So CHM functionality should be independent of the Oracle database that's running. CHM is just a monitoring entity. And it runs in a separate home, the GI home. So it should be completely independent of the Oracle database that's running.
I see. Okay, so you mentioned that it was introduced in 11.2. So can you sort of give me an overview of how it's evolved up through 18, just in a brief overview fashion?
Right. So there have been many features that we have added over the years. So obviously it won't be practical to probably go through each and every entity that we had added. So I will go through a certain key things that we have added. So we have added monitoring of ADVM and ASM instances. We have added tagging functionality for the disks. So essentially, as part of disk metrics that I had referred to in the earlier slide, we tag each and every disk if it is an Oracle disk. So the disk would be used by, for instance, CSS for voting functionality. It could be used by OCR. It could also be an ASM disk. So as part of each and every disk metrics that we report, we also tag that disk with an appropriate tag indicating who is utilizing that particular disk. We also tag the interconnect, whether it is public or private in terms of clusterware usage. We have added process categorization over the years, the one that we had looked at. And over these years, we had also moved from using BDB as our central repository to using GIMR. So previously, we were using something called BDB, which is an embedded database that runs inside ologgerd. One downside with that was that whenever there is a ologgerd shift, basically the data can potentially get scattered over the entire cluster. So previously we had something called ologgerd and a replica ologgerd. And if there are multiple shifts, basically all this data that was stored in the node prior to the shift over had to be replayed to the new node. And this over a period of time can basically cause the data to be scattered all over the place. But with GIMR, we have all this data stored in shared storage. So we had that issue sorted out. And that was not the primary reason why we actually shifted to MGMTDB. The main reason was that we actually wanted to harness the power of SQL and Oracle database so that we can basically open up this data for data analysis and diagnosis. Additionally, we have also added mechanism to capture first failure diagnosis in an autonomous fashion. So this is done through event mechanism. Basically, various components, whenever they run into some problems, they actually raise an event. And we actually, as part of that event, undertake some actions that would aid in diagnosis.
Mm-hmm. Okay. So you mentioned these events. I assume since you're referring to availability events, you're talking about like CSS and GIPC events? Correct.
So yes, so we basically listen for various events from CSS, GIPC, and also from RDBMS. And we basically use those events to further aid diagnosis. So as an example, CSS basically raises an event whenever it's close to missing a heartbeat. So as we all know, right, CSS is extremely sensitive to heartbeat, network latency, and all that. So if CSS is close to expiring its network timeout, it basically sends an event to CHM. And as part of that event, we actually go ahead and issue commands like ping, trace route to actually see whether there's actually underlying network problem, or is it because of something related to software, or is the problem actually with the underlying network. Similarly, GIPC could be raising certain events whenever, so GIPC has something called GIPC HA protocol. So as part of that, which is used by Oracle as part of communication. So as part of GIPC HA protocol, they actually have acknowledgements that they maintain. So they actually maintain connection from every node to every node. And as part of that, they also track how many acts are they receiving. So if they actually notice that they are not getting acts for a particular pair of nodes, they actually send an event to CHM saying that, okay, there seems to be some communication issue between node 1 to node 2. And they request us to basically capture certain information like TCP dump. So they would say that, can you basically capture certain packets on node 1 and node 2 on this specific protocol, on this specific port, to see whether what is happening to these packets, how are these packets being lost. Similarly, we have things for RDBMS as well.
Okay, so this is sounding very similar to functionality that was contained in a product, diagnostic product called OSWatcher that has been shipping for a while. Can you differentiate how CHM is different from OSWatcher?
Right. So CHM is designed to basically work in under duress. So the idea is that when the system is under stress, we would want to be able to capture last gasp data. So as part of that, we basically, so this is all written in C. So these are not scripts. And we don't fork any process to actually get underlying metrics. So to basically make sure that we actually can successfully collect metrics under stress, we actually run real time, and we also log down our memory. So that is one part. So basically ability to collect data under stress. Second thing is efficiency. So as I was saying, the aim is to basically be able to collect all this data in as efficient manner as possible. So we actually use native OS interfaces to basically get all these metrics. We don't fork any external utilities or tools to collect our core metrics. So as an example, on Linux, we get most of the data from /proc. So it's one. The second thing is efficiency, and the third thing is clusterized view. So as part of OSWatcher, one can basically get to look at only node-specific data, and as part of CHM, one can basically get to see the clusterized view. So the one that we looked at as part of Oklumon dump node view, which had all nodes option and even the EM view. And then the fourth point is basically better contextualization. So we have better insight into the things that we are monitoring. OSWatcher doesn't have that insight. It's much more generic. We actually know the things that we are monitoring. We have tighter integration with the components like CSS, GIPC, daemons, and obviously, as I'm probably repeating it again, but basically this data is again consumed by upstream tools. So there are custom protocols through which all this data is exchanged in an efficient way, as opposed to OSWatcher, where this data is not open to upstream tools. That is another point. And then the other part is again event-driven data collection. So OSWatcher basically repeatedly forks a bunch of processes once in every 15 seconds, I guess, by default. CHM can also do event-driven data collection that we just talked about. Various components, they can generate events when they are seeing some problems, and we can basically collect specific data that can help diagnose that specific problem.
So this is sounding like a second generation improvement over OSWatcher, but
Correct.
Is there anything preventing me from sort of running them together if I so desire?
So yeah, if one wants to basically run them together, yeah, I mean they can be run together, but the point is that it is not really adding any value, and additionally, one would be burning more OS resources by doing so. We have actually plugged most of the gaps in terms of the data that is being collected by OSWatcher. So we collect all the data that is collected by OSWatcher and also more. So we are like a superset of the data that OSWatcher currently collects.
Okay, so speaking of those collections, do just like OSWatcher data, does CHM data get uploaded to Oracle Support Services, as an example, for use in SRs?
Right. So as I was saying, since CHM is integrated into the stack, basically what happens is that all this data automatically gets collected through TFA. So there is no manual intervention required. All the relevant CHM metrics are automatically collected as part of TFA.
So when I run a TFA diag collect in anticipation of a support request, it will automatically pick up the CHM data as part of its collection process.
Correct. Correct.
I see. Okay. So speaking of collections, are there any third-party APIs to access this data from my own tools? For instance, Kiran's question about New Relic and AppDynamics. I mean, do we have the ability to integrate our data into other people's tools?
Yeah, so we have some plans to potentially expose this data through REST interfaces so that it would open up our data to any third-party tools that want to consume our data. So we would like to get some feedback here from the audience, whether they have any use cases in their mind currently. They can probably respond over the chat if they have any. This would probably help us.
Okay, or they can, those who are watching this video after the fact could actually email myself with regards to any requirements they might have in this space.
Correct.
Okay, so wrapping up here, we're getting close to the top of the hour. I'm going to open it up once again to anybody in the audience here who might have any further questions that they want to type into the chat. Please do so. Give you a second or two to to enter any questions. I think we covered the topic quite extensively. Thank you, Prasanth.
Yeah, thanks.
Okay, I don't see any questions yet. I want to point out that this is a regularly scheduled event every fourth Tuesday of the month. And our next one will be a very special one because I will have as my guest Angelo Priscino, who's the Senior Vice President, basically my boss, of this group, about actually the origins of the Autonomous Health Framework and his vision for the entire product space. So I look forward to everybody attending that session because it should be quite valuable. And so finally, this will be available on Ask Tom Office Hours on YouTube in the next couple days. So please subscribe to that channel and get your latest information on any of the AHF components. Actually, as of this broadcast, we basically have covered pretty much all of them. I think there's only one left. And so each question will have a direct index into it, so you can very easily get your questions answered through these sets of presentations. So with that said, I want to thank everybody, and we're going to sign off. Thank you, Prasanth, for your time and information. And we'll look forward to seeing everybody next month.
Yeah, bye. Thanks.